Hi, my name is Will Pincek. I work for Juniper Networks, and I'm an education services engineer. And today I'm going to do a learning byte on the Contrail Enterprise Multicloud, and specifically having the QFX10000 act as a data center gateway. So what is the data center gateway use case? So it's going to allow for routing of traffic between an overlay network and the underlay, or out to the internet. So if we look at the logical view, which is this upper corner over here, we see that there's a Contrail virtual network, and we're going to attach a virtual machine to it, as well as a bare metal server. We're going to do that, attach the bare metal server over a top-of-rack switch, and Contrail Enterprise Multicloud will automatically configure this for us. Now in this learning byte, I won't show you how to do that. I have a separate learning byte that shows you how to do exactly just this portion here, and that's called VM to bare metal server bridging. Okay, so I won't go over those steps to make that happen. What I don't cover is this adding of a logical router to route out to the internet. We want to be able to route traffic from the VM1 or bare metal server, not only between themselves, but also out to the internet and back. Okay, so in order to do this, we're going to end up doing the QFX10000 will attach itself through the configuration of CEM. CEM will configure it automatically for you. Attach itself using IRB interfaces to this overlay network. Okay, so it's going to attach it to the overlay network using EVPN VXLAN tunneling. So thing to note down here is that for traffic going out of VM1, traffic will get passed to the V router. The V router will encapsulate a VXLAN encapsulation and send it to the default gateway. Now the default gateway will be an IRB interface on the QFX10000 and will probably have an IP address of 192.168.1.1 when we're finished. And that's because of the gateway setting of the virtual network. And then let's see. So that's that. The bare metal server, when it sends traffic out to the internet, it's going to send traffic to its gateway, which again is the same IRB interface on the QFX10000, which has the 1.1 address. They'll forward it up to the QFX5100. This 5100 will encapsulate it into VXLAN encapsulation, pass it to the 10K, and then off to the internet. Some of the things to note is that the Contrail control node supports type 5 advertisements by default, and that's exactly how it advertises the MAC address of VM1 up to the QFX10000. For the QFX5100, the older QFX5100s, they only support type 2 advertisements. So type 2 advertisements are advertisements of MAC addresses. So they will get placed in a bridge domain here on the QFX10000. The VM, the type 5 advertisement is an advertisement of a network, the /32 192.168.1.100/32 network, and it will get placed at a routing instance up here, which we'll see on the next slide. So this is what it looks like now on the 10K itself. Okay, on the 10K, okay, you're going to see that we have a routing instance. So the logical router functionality comes into play here as a routing instance on the QFX10000. We will see if we were just routing between two subnets, we would see the routes here in the network. But in this case, we see one network, the /24, across that with the next top of the IRB interface. So that would be able to get you to any top of rack switches that are advertising type 2 route. They get routed off of this single bridge domain. Okay. But remember, we received the route from the V router. The Contrail advertised the VM's network, the /32 network, as a type 5 route, so get placed in the VRF and associated with the VXLAN tunnel directly off of this routing instance. So to the VM, it'll go directly across the VXLAN tunnel to go to the bare metal server that's advertising type 2s. We'll send it out using the /24 address. Any traffic coming in the reverse direction will get sent out this IRB interface and then get routed across a VXLAN tunnel directly from the bridge domain. Okay, now I actually cover in a separate learning byte, I cover central routing for IP fabrics with a EVPN overlay. I think I just call it central routing. Is my learning byte. So that covers what goes on in here, but there's something new that's different from that, is that, again, we're trying to get out to the internet. So instead of routing between two VXLAN tunnels or two virtual networks, we're trying to route out to the internet. So what happens is when you configure this logical router, you're going to specify, you're going to make this public. And when you do that, it's going to install this 00 route with the next table of INET 0. So any traffic coming inbound from in this direction, from bottom up, anything destined to the internet will get passed to this table and get routed based on this table. In this case, it'll get routed out to the internet. In the reverse direction, when traffic comes back and is destined for 192.168.1/24, traffic's going to end up wanting to be routed off of this INET 0 table, but there's a firewall filter in place that says any packets that come in with this destination then route off of this table. So we do filter-based forwarding, and then traffic will get routed to its appropriate path. That's what we're going for. So in order to do this, we need a Contrail cluster with the Contrail Command user interface in place. We need VXLAN routing enabled. We need an onboarded IP fabric with an EVPN VXLAN overlay established. We need the spine nodes assigned both the CRB gateway role and the DC gateway role. Okay, the CRB gateway role alone allows for routing right here under the routing instance. By making it DC gateway role, it's going to allow for this forwarding to next table, this filter-based forwarding. It's going to allow for that. Okay, so give it the opportunity to do that, but you still have to configure it to do so. So here's what we have in our lab. We've got an IP fabric, okay, running eBGP between all devices so that we can advertise these subnets. So these are all reachable subnets from one another. So like for instance, I can ping compute 2 from compute 1, for instance. I can reach all that. There's also a default route off of here pointing to the internet, which should have probably been on this slide. But this is my Contrail cluster. I've got an OpenStack node. I've got a control node. I've got 2 compute nodes that both act as an OpenStack compute and a Contrail V router, and I also have a CSN that's going to provide DHCP and DNS services for my bare metal server. I also have a command node, a command server out there that's running the command UI, so I can control all this stuff from the command UI. I also have already onboarded this IP fabric, right, onto, it's a brownfield IP fabric. And what that does is establishes a IBGP EVPN VXLAN overlay across these devices, including with the control node. So this QFX10K is acting as a route reflector for our EVPN sessions. And it has a EVPN BGP session with the control node, QFX5101 and 5102. So let's go ahead and start to make this happen. First off, I've done some things for you, so all we're going to do is verify some stuff initially before we create our logical router, which is where the magic happens in this, okay? So first off, we want to verify multi-protocol BGP. So I go to the 10K, and if I say show BGP summary, I sure enough have my eBGP sessions for my underlay, and then I have my EVPN sessions to QFX5101, QFX5102, and then the control node as well. Okay, so I can receive routes from Contrail and advertise routes to Contrail. So that takes care of that verification. Then we want to verify our CRB roles of the fabric devices. So I go into the Contrail Command node. I'm going to go to my fabrics. I've got a single fabric here. I want to make sure that the QFX10K is a route reflector, DC gateway, and the CRB gateway role. Gives it the ability to act in those roles, but you actually have to configure it to do those roles later on, which will show you how to do the DC gateway role. And that's when we get to this create logical router. That's when we actually make it do that role. And then the 5100s are both CRB access. We want to verify VXLAN routing. In order to be able to support those routing tables we showed you on the 10K, we need to go make sure under projects, under admin, that this slide button is enabled for VXLAN routing, which it is. Then we also, we want our bare metal server. If I go back to this one, remember our bare metal server is going to get its address from DHCP, so we want to get it from the CSN. I have a learning byte on what the CSN's purpose is, so feel free to watch that. But so the bare metal server is going to get its DHCP address from the CSN. So what we need to do is associate the CSN with this QFX5100. So let's make sure that that's done. It is, but I want to show you. So I go to Fabrics, I go to Brownfield. 5102 is the one that's going to have the bare metal server off of it. So if I go under Edit, it's here that we associate our service nodes. So I associate the CSN top of rack service node to the QFX5102, which it's already done. So we verified that. Our security group needs to be adjusted to allow for ingress traffic to our VMs and our bare metal server. So if I go to security groups, I'm going to verify, and I have modified it to allow for ingress traffic from any address. So just make sure you have that set. So that's done. I want to verify my virtual network. So on my virtual network, I want to show you that I have a virtual network called VNA here, and I have two instances attached to it, a bare metal server and VM1 are attached to it with their addresses of 101 and 100. Okay, let's see. What else can I tell you? Subnet 1 is providing gateway is 1.1 and also the DNS server is 1.2. Okay, and DHCP is enabled. So good. Okay, that's all good. We verified our virtual network. We've pretty much verified our virtual machines here because here it is, VM1, and also our bare metal server is up and running. I want to show you that the bare metal server can ping the VM. So here's my bare metal server. I'm going to say IF up ETH1. Hopefully it gets an IP address. So this is the bare metal server, which it does. And here it is, and I should be able to ping the address of 1.100. Okay, so I can ping that. And I'm not really sure if I can ping the .1 address, which I can't. And the reason why is because I haven't actually done anything on the logical router, or sorry, the spine node, right? We haven't done the configuration for that yet. The way we do that is we don't have to manually configure it. We're going to actually do that by configuring a logical router. So just to reiterate, we verified all this stuff. So we've onboarded Brownfield Fabric. We've launched a bare metal instance. We've launched a VM. And they can ping one another, but they can't get out to the internet. So we're going to enable a logical router, which is the next step. Okay, so we're going to go over here under Overlay, under Logical Routers. We're going to create a new one. It's pretty simple. Okay, it's a simple configuration. I'm going to call it Logical Router A because this is for the A network. I'm going to extend it to the QFX10K, and the network I want associated with is VNA. And the trick to make it, now that alone, if I hit create, will only make this a CRB gateway. It'll route between different subnets. That'd have to be a second subnet here to route between. But in this case, I want to be able to route to the internet. So that's when we click public. That's going to allow for that filter, the firewall filter, to do filter-based forwarding, and also for that extra 00 route that points to INET 0. That's what this is going to get you. So I'm going to hit create. Now when I hit create, this is going to automatically have Contrail Enterprise Multicloud go out and configure using Ansible scripts the spine nodes. In this case, we only have one spine node. The thing I use to troubleshoot is this command, tail-f/varlog Contrail fabric Ansible playbooks.log, and I do this on the control node, control node. And here I'll see that the Ansible scripts are running. And if anything goes wrong, a lot of times I can figure out why here, but usually nothing goes wrong here during this process. So we're going to wait for this to complete. And what it's doing is the Contrail Control node is building the local configurations that it's going to push out to the spine node for routing. So it's going to push out the config for, if I bring this back up, the config for the IRB interface and associating with the VXLAN tunnel, this bridge domain it's going to configure. It's going to configure this routing instance. It's going to install this 00 route that points to INET 0. It's going to install this firewall filter that will push any traffic destined for the 1.0 network down to be routed off of this routing instance. It's going to do that all for you, which is a lot of config. And all you had to do was click a few buttons, right? Kind of nice. That's the beauty of Contrail Enterprise Multicloud. So I'll wait for this Contrail, for this Ansible script to finish, and then I'll come back to the video. Okay, so our Ansible scripts have completed successfully. So now we can go out to the QFX10K and verify the routing. That's our next step. So just take a look here. I like to go in and just look at what was changed. So I say show pipe compare rollback 1 will show us the changes that just occurred. And I'll just briefly go over. So here we've got some policies. Good enough. Okay. We have a loopback interface configured, and that's to keep make sure that there's always an interface available in the routing instance. So here's our routing instance. Hold on, let me go back. So we have that. We also have a firewall filter, okay, applied here under forwarding options, okay, and it says for anything destined for 1.1.1, then route on this routing instance, right? So this is for inbound traffic coming back from the internet, just like we looked at, right? So there's the firewall filter for filter-based forwarding. Here's the routing instance, which has the IRB interface on it, which we don't see the IRB interface here in the output of the command. Sometimes this comes in as 2 commits. So if I say rollback 2, I'll see more. So here, sure enough, yeah, now I see it all. I see, let me go back up here. We see our policies. We see our IRB interface, right, with the default gateway, virtual gateway set. We see the VLAN with the associated with the VNID, and the layer 3 routing interface is IRB5, which is this IRB here. Good. We see our firewall filter that we talked about already. And then we see our routing instance that has IRB applied to it, the IRB interface applied, and also to allow for, it has a VNID specifically for type 5 routes, which are the ones coming from the Contrail Control node, okay? So there's that. So our routes are going to be in this table, okay? So let's look at those routes. If I say run show route table and then punch in that routing table here, in that route we have the default route that points to the next table, inet0, which is what we had said. We have the /24 that points out the IRB interface to get to those type 2 MAC addresses. And then we have the /32 for the VM to reach the VM, okay? So it's good, okay? So now from either the VM or the bare metal server, I should be able to get out to the internet. So let's just verify that that's correct. Here's my bare metal server. If I say ping 192.168.1.1, I should be able to ping now. I can ping the gateway, good. And if I say ping, let's just try it. I don't know if DNS is working right now, but let's try it anyways. Juniper.net. Yep, sure is. So I can route out to the internet. And that's it. So in this learning byte, we describe the steps to enable that DC gateway function on the QFX10000. I hope that helps, and I hope you enjoy my other learning bytes as well.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.